Okay, so this is actually the second session on how to implement the semantic technologies and ontologies in the federated living labs. Of course, this is something that is not limited to living labs. You can use it for anything you want. But just to recall, the first session was mostly about the semantics itself. Today, we're going to be looking at how to actually technologically implement this stuff. And then the third session that I'll organize in a few weeks will be all about, okay, how do we use this, right? How do we actually get the data we're looking for? How do we query the data that is out there? But today is going to be about implementation. In my invitation, I promised I would make sure that it was suitable for all audiences. I think it is. There's one small section that is not, but it's very clearly marked, so that you don't feel that you have to, if you're not interested in the actual technological part, you can just take a break there or just listen with great interest, but not worry about not following. That's fine. Okay, so that's what we're doing today. It's being recorded, so we're good with that. And so the objectives. The first thing I want to do, actually, there's a pre-bullet, which is just look a little bit again at what we did last time, a little bit of repeat, just to refresh our memories. Then I'll talk about how these adapters actually work. We call them Sparkql endpoints, and you'll see. I'll explain what that is. So you'll if there's anything that you'll take away from this, you'll know everything about what that is and how to explain that to your colleagues. How to install one. I'm actually going to do a live demo, so we'll see if that works. Upload some data, and then we'll have a very, very quick look at getting data back. But most of that is for the next time. So this time is really focusing on implementation, okay? At any time, feel free to stop me. I've built in enough time for discussions. If there are no discussions, we'll finish early, but an hour and a half should be okay. I think that there's enough time to discuss. So without further ado, a short introduction, and I've stolen this from Netflix. I don't know about you, whenever I watch a series, I always do skip intro. Today, we're not going to skip the intro because I think it's actually important. But if you watch this video 6-7 times, then maybe you want to skip that one. So first things first. The first couple of slides I've borrowed from some other things that we've worked on before, but they are very relevant to our discussion here. And the reason they're relevant is that we are dealing with so many things when we're doing living labs, when we're implementing systems for cargo or for logistics. And we can't get around the fact that we have all of these different approaches to exchanging data. Yesterday, myself and some colleagues, we visited some of the airport operations behind the scene. We call that airside. In other words, not on the curb side, not for passengers, but the stuff both on the passenger side, but also on the cargo side. What really happens, and it's sort of when you do that, you realize that there's still an awful lot of paper. Paper is still a really nice medium for recording things, handing it off to someone else, and making sure that everybody can read it. You put stamps in it, you can put staples in it, and all that stuff. So the reality is, we still have paper. You still have paper for sure. Then we have the EDI stuff, which is all about the sending messages to each other. The bulk of electronic data exchange is with messages today, even though we kind of entered that era in the year 2000. Then in this era here, 2020, we're all talking about APIs. And in fact, most of your living labs have APIs as well. And so really, it's all about being able to interact and share data. And if I put the label here, Internet Logistics, because we use APIs, but we'll also use Sparkql endpoints. But a lot of it is actually using APIs. Still using the ontology that we have, but it's using APIs. And we're going to look at that. What's the difference between an API and a Sparkql endpoint? And then the third one is that what the EU is talking about when the Commission, when they organize these new initiatives. It's all about data spaces, and data spaces really is a very nice way of saying an environment where all platforms are connected in a very, very transparent way, which is exactly what we achieve with these semantic endpoints. So in a sense, what we're talking about today is how to create a data space. And I put here, as I said, I use this slide for other purposes. I put the Federated project in here because for me, that's really what we're doing here, is building a data space. Okay, so there is one little snag with this story, and that's this one, is that it takes an awful long time for our industry, and when I say our industry, I mean the logistics and transport industry across the board, regardless of the mode of transport. It takes an awful long time for new technologies to be phased in or phased, and also be phased out. And so unfortunately, our experience is that it's a 20-year time frame. None of us like this. I mean, we would like to be able to do work and see it implemented in a few years so we can go and do something else. But the reality is, as I said, we still use paper. In fact, that arrow should be longer. We still use paper. We use a lot of EDI in 2022. We are now implementing APIs, and it might well take us 10 years before we see those properly implemented, and it may also take us until then at least to start getting going with data spaces. So that's just a reality. I heard an interesting explanation for this the other day. We as human beings, we always remember disruptive events. We will remember COVID. We remember the war in Ukraine that has started not that long ago. These are the things that always stand out. What we don't remember is that a lot of the really good things around us took a long time to come. And so slow change is not something that we notice, but it doesn't mean it isn't happening. And this is an example of that. A lot of the good things that we're building here will take a long time to implement, but that doesn't mean they're not being implemented. It just takes a long time, and it's hard to notice progress even when it's there. Now, I've made another picture here, which is a little bit similar, but I think perhaps more appropriate for our discussion. Again, on the left, EDI messaging. This is the bulk of what we use, certainly in air transport, but I'm pretty sure that other modes of transport also use messaging to a very large degree, EDI. Then now we're in this, and the messaging just on the left, as you can see, it's sequential. I send a message to one party who sends it to another, and so it's very much a bit like email. You send email to someone who may forward it and stuff like that. The web API direct data exchange is the API world. I put one record here because that's our standard, but I could have put federated there, where all parties can interact directly via web APIs. But what we're really working towards is what is technically called a knowledge graph. And a knowledge graph is actually the implementation of lots of different semantic endpoints, the stuff we're discussing today. When the federated living labs start interacting via these semantic endpoints, via these Sparkql endpoints, we will have created a knowledge graph of platforms. And that is quite unique, because I think it might be one of the first ever to have a multimodal knowledge graph using these technologies. As I put on LinkedIn, some of you may have seen that I'm also participating in a conference on knowledge graphs later today, which is partly why I have this beautiful picture. But that's what it is. And we're going to hear there that the rail people are doing this, the rail infrastructure, but I'm not aware of true multimodal platform interchange using this approach. So the stuff we're discussing today is, you can easily say it's cutting edge in our industry. It's well ahead of where we need to, it's absolutely where we need to be, and it's well ahead of where we are. Okay, so this is perhaps an interesting picture to keep in mind. From APIs to knowledge graphs, you'll see that there are some differences. So a couple of slides, well, 3 or 4, to remind you what we discussed last time. So last time we were focusing entirely on semantics, and we talked about the fact that we need to speak the same language, that if you have one living lab and you have another living lab, internally, it doesn't matter, you can have a Swedish living lab and an Italian living lab. A Swedish living lab may be using some sort of technology for internal data exchange. The Italian living lab may be using something else. That's absolutely fine, as long as it's internal. Black box, we don't care. But when they start interchanging, they need to use the common language of the federated semantic model, okay? So that is, again, it's we discussed that. I don't have to elaborate much further, but that is the idea of using a common language in a semantic model. And then, if you may remember, we looked at an example of two living labs, X and Y, that want to interoperate. And same example, it was a Italian transport company that, if I recall correctly, took freight from Rome to Linköping, that's it. And then in Linköping, there was another living lab that was going to do the last mile. And they interact, they say, hello, how are you, and all that stuff. One party says, listen, I've got some data, I've got some freight coming, here's the transport data. And then the last mile confirms, okay, thank you very much. Based on your forecast, we think we'll be able to pick it up and deliver it at these time and dates, etc. So a lot of the questions on the left have been answered. And then if you remember, and if you don't, we've got some slides here. We then said, okay, the Federated Developer Portal, which is online and live as we speak, you can go there and start looking up some of the language that we have developed within the Federated project, like in this case, it's service provider. And then on the right of the screen here, this is the query scheme, by the way. You can see details of what it is, and then you click around. If you can see on the right, it says turtle, JSON LD. It says a bunch of stuff, and you sort of play around with it, and you can find the appropriate language in the appropriate form in order to do some semantic data exchange. Then we said, okay, let's do that exercise. We translate from what would be very common user language, like who will do the last mile, what's the estimated time of departure, stuff like that, into the words that we have defined for the federated environment, okay? So again, still it's just a repeat. Then I've added some color in order to distract you a little bit, but this is, and the bullet shouldn't be there. I don't know how I managed to get them there, but anyway, never mind. This is then the actual sort of the data that the Italian company may provide to the Swedish last mile company. So some stuff about where it's coming from. Actually, it doesn't say that. It does say where it's going to, and what it is, how much is it, when do we expect it to be there, etc. And then there's a response. I'm sorry again for the bullets. Everything's a bit messed up, but these are just copies from the previous slides. And you see that, for example, they now have an estimated time of departure and arrival for the last mile, you know, that they have added. There's some other stuff. I'm just repeating it because when you start looking at this, you may need this data when you start implementing it. So it's just for your convenience. I've copied it here. You can write through that. So this is where the story really starts, is the big question is how do we access the semantic data of other living labs? You know, it's all very well the fact that I'm putting it on a slide, but that doesn't help. And big questions, there are lots of big questions. You may not recognize the image on the right. We know that the answer is 42. And for the rest of it, let's not panic. We'll just go ahead and implement it. And you'll see that everything I'm going to show you, if you were really quick, you could do it at the same time as I'm doing, but you're not going to be that quick. But certainly, when you look at the presentation afterwards, there are some links in there. You can come and follow and click along, and you'll see that by the end of the hour, you too can have your own semantic data hosted, and you'll see what you can do with that. So that's a promise I intend to keep. Okay, so firstly, how do these semantic adapters work? And we have to go back a little bit to answer the question, how do we communicate? If you remember the last time, the question was, what is language, right? So we ended up discovering that language is all about vocabularies and grammars. In fact, we call them ontologies. Concepts are linked, etc. That was fine. We did it last week. You can look it up. You can rewatch the video. The question today is, how do we communicate? And if you start in the top right, this is how some of us, the geeks maybe, the little geeks, we had this thing with tin cans and a wire. Very easy. You can talk to your friend who's all of 20 meters away and whisper, and you can hear each other. Then, of course, we moved on from there. We had these telephone exchanges a century ago, roughly, where people were literally just making connections with electrical wires rather than cotton wires, and connect people and allow them to communicate. we've moved on from there, and what's interesting, well, for the technical geeks or the ones that used to have tin cans before, is that picture before, people literally plugging in cables, and we've replaced that by Ethernet cables on the right there, where we can actually programmatically change how wires connect, but there's still wires that are still connected to some sort of system or server that allows us to exchange data. And from there, we make the step to the website there, the virtual world, where we can connect with each other just by typing in a URL or typing in a number on the screen. Okay, so we've gone from physical connections to virtual connections. You can see that here. So that is how we communicate. Now, question is then, what is an endpoint? And each of these examples have endpoints. The tin can is an endpoint. It just literally means it's the end of the cable. It is where the cable ends and where we stick something close to our ears. And so we have endpoints for the tin can, for the telephone exchange. We have endpoints where the cables plug into a server. And we have endpoints that are essentially a URL. And in the context of our discussions, we actually often refer to these URLs or URIs as an endpoint. So when you have a system that allows you to exchange data, such as a website, such as a server, such as an API, such as a semantic endpoint, essentially what that means is that whatever that URL is the endpoint. So in this world that we're talking about, an endpoint is really a virtual endpoint. It's no longer a physical end of a cable, but it is where the communication sort of ends and comes to you. Your interaction with that system is the endpoint. So now we can make sense of stuff. Forget the stuff on the left here. That's really just to confuse you. And look at the stuff on the very, very right. We have seen that we have the concept of tin can endpoints, you know, the wire, and we sort of worked our way up to messaging endpoints. And so a lot of our systems still use that, and they're endpoints that allow us to send messages to and from. We then have the API endpoints, which allows us to get data to and from servers. And then we go all the way up to semantic endpoint. And if you want to be a little bit geeky, you can look at the column just next to it, where we say, okay, we had cables. I think that regardless of your background, we know we have cables. There's probably a cable on your table somewhere. Certainly for me, there is. That is carrying bits and bytes. I know we have wireless as well, but let's say that we just stick with the good old-fashioned cables. They're a bit faster anyway. So the cables, they have bits and bytes, which is just electrical signals. And then the way that the stuff is built up is that you combine the bits and bytes into chunks of data. And this is very physical. When you make a phone call, whatever you say is chopped up into chunks. And they may be sent via satellites or cables or whatever, but it's all the chunks. And then what we do at the next level is data connections, where we put the chunks in the right order. And then we say, okay, as long as we have all of the data chunks together in the right order, we now have a data connection. And so you work your way up. Now that we have data connections, we can exchange characters, in other words, letters. We can form them into words. We put them into certain data formats. And we then talk about structures. And now we get to language. And this is where we want to be. And the semantic endpoints at that level. And although we didn't do it here, you could actually put dates here in this whole thing. And you'd see that the whole cable story starts at the end of the sort of the 18th, 19th century. And every time we go one level up, another 10, 20, 30 years passes. So there's a lot of super interesting engineering history here. The image that I've sort of tried to blank out a little bit, the only reason I put it there is you may hear this one day. You might hear somebody use the term OSI stack or semantic stack. What they're just referring to is this story on the right. The OSI stack is about the technical stuff, the cables and the bits and the bytes and all that stuff. And the semantic stack is all about simple formats that we all use, like a URL or an XML document. And then we sort of work our way up to super complex things which are being used in AI. Okay, so this is how computers communicate. But it all starts with, believe it or not, the simple concept of a tin can communication. So what is an API endpoint? Let's talk about API endpoints first. This is one that you all know, because when you go to a website and you want to get information from a server, from a web server, we sometimes call them websites, but essentially it's a server that has data, and you want to get that data. So what you do is you type in a URL, you copy and paste the URL in the appropriate place in your browser, and what happens is that your client, we call that your browser, will send a request to the server. This is called an HTTP request. It's a complex word, hypertext text protocol, hypertext something protocol, transfer protocol, apologies. Anyway, that doesn't matter. It's just a digital request with the URL. And sometimes we include some parameters. For example, if you want to go book a trip somewhere, you will put a, you don't know this, but when you type stuff in a website, behind the scenes, they create a request URL, and they include some of the parameters like the dates that you want to leave, the airline you want to fly on, the class you want to fly on, all that stuff they call parameters. They put the whole thing together into a string. You can often see that as well. And then it goes to the server. The server thinks about it for a bit, looks in its database, and gives a response in some suitable format. And most of the time that could be HTML. You may have heard of that. That's the stuff we need to make the screen look nice, like a nice page. But it could be video, it could be sound, it could be all sorts of different ways for it to give the information back in a suitable format. So this is an API endpoint. And so when your colleagues talk about, oh, we need to have an API, what they're really talking about is the one to have a system in place that allows some party to send these requests with some parameters and then get a response back. That's an API. That's all it is. The history of API is another story, but we're not going to go into that. Now, what's a semantic endpoint then? Well, as the picture gives away, it's actually very, very similar. It is still a client that does a request to a server, and the server still gives a response to that client. So that's the same. The difference actually is in the very top there, where instead of in the previous slide, I said URL plus parameters. Well, here I say URL plus data query in Sparkql format. And so in other words, instead of just asking for something simple, like give me the price for a flight ticket on this day to this destination with that airline, that would be the previous example with the API. Here, we say something more complex. We say something like, give me all of the airlines roughly around these dates and their prices. Different question, it's not as specific. And because we do that in that Sparkql format, which we'll see, we can have more complex questions, more complex requests, or queries is the term we use here. Query is the term we use in database technology. It means asking questions, okay? So we can ask more complex questions across the internet to another server, okay? On the left, I've repeated what Sparkql endpoint is. I think it's a silly acronym, but it doesn't matter. It sounds good. Sparkql protocol and RDF query language. If you don't know what that is, if you don't know what RDF is, then you still haven't learned anything. But it doesn't matter. It's not important. Sparkql is easy to say. So that's a Sparkql endpoint. Okay, very similar to an API, but just that bit more sophisticated. So let's compare these two, because there's an important distinction that we need to agree on. Firstly, the API has fixed parameters that we can include, like I say, some dates and things like that. And that works if this allows you to describe your question. If fixed parameters are fine, then you can use an API. When do you do that? When you're always asking the same question. So for example, if you go to a weather website and you want to have weather forecast, most of the time you'll see that you always have exactly the same question, which is, what's the weather at this location for today or tomorrow or the day after, okay? So the questions don't really change. The place that you want to know about may change, but the very fixed parameters, very fixed questions. Therefore, APIs are great. And it doesn't have to be as simple as weather. It could be complex. You know, when you do make a travel booking, there are lots of questions that you want to ask, but that's fine. We have lots of parameters, but the nature of the question doesn't really change. Okay, same sort of question. Sparkql endpoints, we use them when we don't really know in advance what's the question. It could be the weather, it could be a flight booking, it could be a question about congestion, it could be a question about what are the visa requirements, lots of different types of questions. Then you don't really know in advance what the question is going to be. And then Sparkql, using semantics, using language, is a nice way to have that conversation via digital means. And so you always have the same type of data with your partners. You should and can use, or can and probably should use an API. If you need to deal with different data, new questions with perhaps unknown partners, then Sparkql is a great option. And now we'll take it all the way back to Federated, because if you remember, I asked you a question last time, and it's been asked a few times, how can different living labs interact? The first question that's going to come to your mind, I have no doubt, you ask yourself, well, I don't know. What am I supposed to exchange with the other guys? I have no idea. And that's exactly when Sparkql is great, when you don't know yet what it is that you want to exchange data on. And that is, I think it's an important distinction, that use APIs for the common questions and use Sparkql for the unknown questions. Okay. And that also, when you talk about unknown questions, if I say a term like artificial intelligence or intelligence, you can see that you're getting into an area where there's lots of unknowns, right? Which is why the whole semantic story is very closely linked to artificial intelligence. But that's for another webinar, that's for another project probably, but there is a link there. So API versus semantic endpoints. So now we're going to be talking about, no, not yet. I think there's another slide on this topic. Yes, okay. I've written it out here, and I'm not going to read it all for you. You're more than welcome to read it. But again, Federated is really about connecting lots of different platforms that have lots of different purposes, that may be in different countries, for different cultures, for different ways of doing business, maybe even different language, maybe platforms that haven't been invented yet, but they will be invented in the next 5 years, 10 years, wherever. And so if you want those platforms to interact, Sparkql endpoints is your friend. This is where you have to go. However, if you look inside a specific domain, for example, in the aviation domain or the maritime domain, you may have existing systems, existing data sets, existing whatever it is you have, old systems, legacy systems. You may well be using APIs there, or even messages, or even paper, but I didn't put that there. And so within your community, you may or may not use Sparkql, but almost certainly use APIs and messages, and that's fine. The point here is that Federated is about the interconnectivity between the platforms. What happens within the communities that use that particular platform is fine. It's nobody's business. So we're not asking anyone to change an existing living lab. The EU is not going to ask anybody to change any legacy system. That is not what it's about. It's only for the interoperability. And then when you sort of think that through, you'll fairly quickly realize that perhaps these Sparkql endpoints are really what creates this data space, but it's not going to replace all of the existing technologies. That is, it won't. I don't think it will. I don't think it ever will, but never say never. So anyway, here's an important picture took forever to make, so enjoy it and have another look at it, but I think it's important. So it's all about in between the platforms. Before I go further, I've done a lot of talking already. Does anybody have any thoughts, reactions, questions? Are you still there? And by the way, I can't see hands raised, so if you want to speak, please just speak.
I was thinking, would you say that it's the best advantage, or the most important advantage between GraphQL and Sparkql because they more or less cover the same problem about unknown questions in advance. So I don't know, I was just wondering while you were exposing the Sparkql advantages.
Right, okay. Yes, so, okay. I didn't mention GraphQL. There are some other query languages that are dealing with these graphs. I wouldn't suggest that one is better than the other. Sparkql, I think, is more, I've used that here because it's commonly available, it's free, it's open source and everything. GraphQL, I think, is a commercial format. I can't remember. Is it Facebook that has GraphQL? Do you know?
I think so, yeah.
Yeah. So I think GraphQL is a Facebook development, but it's very similar. You know, it's a bit like, for those of you that have worked with systems before, you may have heard of SQL or databases, relational databases. And so you have SQL Server, they call it, and you have Oracle, and they do the same thing. And in fact, the languages look very, very, very similar. I think that Sparkql or GraphQL or other query languages that exist or that will be developed over time will have the same similarity. And so, so I think they'll be interoperable. I don't think one is better than the other. Interestingly, when I said that, I don't think that we're going to see Sparkql everywhere, and that we will still use APIs and messages for a long time. The reason is that, from what I can tell, these complex queries that we're talking about are actually quite demanding. It takes a lot of processing power to, well, a relatively big amount of processing power to execute. There's more data involved, and so if you look at the systems where you have very, very high volume of data that needs to pass in a very short time, in particular if the data doesn't change, we are probably never going to use Sparkql for that, and we'll use APIs. And so we then bring in the story of something like GraphQL, which is similar to Sparkql. The difference may be that one is more performant than the other. Given that it's a commercial implementation, it may be faster, which is why perhaps you have to pay for it. And I think we will certainly, if you look around, there are some really good databases for this, and probably the higher performance they have, the more you'll have to pay for them. But for our purpose, we can use Sparkql certainly in a federated environment. But you're quite right. There are alternatives for sure.
Okay, thank you. It was just a question that came to my mind.
Very good. Okay. That's why we're here. Any other questions that came to your mind? Or someone else's mind?
I like very much the way you present the Sparkql from an end user point of view. 10 years ago, we would speak about transactional systems and analytical systems. Remember?
Yeah.
But you seem to agree that APIs and Sparkql will go hand in hand when the two needs to be integrated. When we have a very stable API and transactional environment where the owner of the data wants to control really what is happening, the last thing he's going to start with an API and then move to Sparkql, to an endpoint, when he gets confidence what is happening with his data. Is that a good point of conclusion?
Yes, you're absolutely right. And I'll take you back to the most complicated picture I've shown you, and that's the one here. Now, if you now look at this complicated picture here, you remember on the right, it had semantic endpoints. There's sort of, you can see them. There's this yellow box that's querying Sparkql, but what you can see is that box is sitting on lots of different layers, you know, RDF, XML, Unicode, and then we have the transport, network, data link, physical, and everything. In the end, everything goes via an electrical cable or an electrical signal in the air, okay? And so there's all these layers of complexity. And so even today, even though the very bottom layer with the bits, you know, physical, even though we have all of these other layers, people still use these. Engineers go to the very bottom, the most simple connections, if they want super high speed. So it's not because we have semantic endpoints that we won't be using API endpoints because they're more complex. And so even messages, we will still see messages in the future. And so really it kind of depends on the application. I think for our environment, European data spaces for logistics and transport, that's fairly intelligent level already, and we can use Sparkql. But if you want to do, for example, you build yourself a nice tracker system that will track exactly where your freight is. For example, you have a shipment of clothing, Inditex for Zara, you put a tracker in there. You will probably want to have as much data as often as possible with the least complexity. You're not going to use Sparkql there, at least not for that connection. And so, yes, it all depends on where we are. For our environment, federated, semantic endpoints is absolutely the right place to be. This is what data spaces are going to be all about. But that doesn't mean that all the other stuff on this diagram you see here won't be used. Yes, it will. We're going to use that forever almost. Okay. Right, then I'm going to move on. I think this is where stuff gets, okay. Install your own semantic adapter. This is where the rubber hits the road, right? This is why you came to this webinar, hopefully. So I'm going to first do a very short course on architecture for those of you that are not architects, which is probably at least half of you, if not most of you. And architecture is a lot easier than it sounds. You basically, you take a bunch of components. I've used Lego as an example. You stick them together and you have something. In this case, I think it's a PC. But you can make anything with these Lego boxes. And although this may seem like a almost silly definition of architecture, this is what people do. They build stuff, and some people, they go to school and they learn. And if you look at the example on the left with the Architecture for Dummies book, and learn how to design bridges with calculations, how, you know, when is the bridge going to break, how strong is it? Is it too strong? There's a building next to it. How many stories can I build before it collapses? Yes, of course. There are people that do these calculations. In fact, very often architects don't do the calculations. They have someone else to do that for them. But when it comes to it, it's just stacking up bricks together. And so if you can understand that, then you're hereby qualified and promoted to be an architect. So we're going to use your skills immediately. And so how are we going to add an endpoint to your living lab? So I have an example here of a living lab named Awesome Transport. And we have the option of adding a Sparkql endpoint or an API or a message endpoint and who knows what. And if I were to ask you, without having seen the next slide, how would you do that? In fact, if you can't answer it, you can ask your kid, your child, and I'll say, well, daddy or mommy, I think it's all daddies here, but anyway, maybe mummies as well. No, there's mommy, yes. You ask your child, could you do that for me? They'll just take the box and block and stick it on top, and it will be absolutely right. This is how you build endpoints. You take an existing system and you just add the API or the Sparkql endpoint to your system. In this example, I haven't used the messaging endpoint because I didn't need it, but it's just an example. And I put two APIs because you can have multiple APIs on the same system. And I had added a Sparkql endpoint, right? So this is architecture. This is what architects do. And so the only reason why, when you listen to architects, why you think, oh, I don't understand the word they're saying, is because they use words that you don't know, not because of what they do. What they do is easy. They just use a different language. So, but we now know the language as well. We know API, we know Sparkql. So as new architects, we're going to say things like, well, I've added a couple of APIs to my system and I decided to add the Sparkql endpoint as well. Great. This is what architects do. And now you're an architect. However, what you don't know yet, but we're going to look at it in a minute, that this may be complex. You know, it's easy to put the little block on. And honestly, most architects don't go any further. The next step is to give it to some engineer and then we'll make it work. But the architect's job is done. This was the easy part. So then the next option is that you say, you know what, I don't know about implementing Sparkql. It's new to me, I've never heard of it. In fact, when you talk to your architect and IT colleagues, they will probably say that. They say, well, I don't know what Sparkql is, never heard of it. And you give them this presentation and they'll crown you to be the next head of architecture. But they'll say, I don't know what it is. And because I don't know what it is, I'm going to play it safe. I will not implement the Sparkql endpoint on my system. What they can do is the second option is that you kind of leave it separate and you connect it to one of your APIs. That works. It works just the same. You still have a Sparkql endpoint. It's just not part of your system. It's sitting separately. And then it's a third option. For example, you have this guy here, Little Lab. You know, it's only little because it didn't have space, but Little Lab decides that they don't want to do any of the work. And so they only have one API implemented anyway. And so they're going to connect to exactly the same Sparkql endpoint that the awesome Transport Lab has done. And so they're sharing the same Sparkql endpoint, like a third-party system almost. So lots of different configurations, but all of it is just messing around with Lego. That's literally what architects do. And they do this. What I'm showing you here is what they do. They'll stick it on in the heads or on a nice PowerPoint with awesome words. And then they change it and say, no, what if we did it like this? What if we put it here? What if we put it there? That's what architects do. And then they look at the advantage of doing one or the other. So let's do that. So the first one, you know, is when you put it all together, you get a better system for sure. You get more speed, you get more performance, and you have a really good control over data security. So this is what people will do if they build a system that is permanent. If they build a system that's going to be here, going to be used by thousands of customers, a lot of queries and stuff like that. This is what they will build. It is it's more complex, and at the very bottom, as you can see, your colleagues will probably not approve this because it has a lot of impact on the system. You don't just do that. It creates new dependencies. They have to do lots of testing, and so they may say, you know, I like the idea, but we're not going to do this. So let's go for option 2. Is happy to implement Sparkql for you, but we're going to do it on a separate server, on a separate system, which is easy to implement. And we're now no longer, the two systems don't depend on each other. And surprisingly, because they're using an existing API, they have a lot of control over the data security because the API is already secured. And so by going, and essentially it's a bit like saying, well, I want to have another door to my house. If you put it in front of your existing door, then you keep the security of the old door and you just have a new door in front of it. I don't recommend you do that, in particular if the door's open the wrong way, because you'll never get out. But that's the sort of the idea. There are some disadvantages. It's a bit slower, and you know, not only do you have to now manage the access for your existing API, you have to now have a second level. You have to do for the Sparkql endpoint as well. But fine, it works, and you'll find it's a much easier to convince your colleagues of doing that. The third option is, oh yeah, it's a bit like, sorry, I have an example here. Let's say that you have a laptop, I'm almost certain, and that you have a USB hole in there, what you call it, a socket or a plug or whatever. And then somebody comes along and says, no, I have a much faster USB connector for you, but it is a different shape, right? Now, you can do two things. Option 1, this one here, will be that you literally take a drill and you drill a hole in your laptop and you open it up and you add a new connector. That's one way of doing it, but as you can understand, your IT department will not be happy if you start drilling holes in your laptop. But what they don't mind is if you buy a little converter cable, stick it in, everybody's happy. That's what this example is. Is you essentially, you add a Sparkql endpoint through a converter cable. That's what it is. So that's easy, right? We can all get our head around that. And the third option is for I was just about to say for the lazy people, but it's not. The option of saying, well, if Living Lab X has already done it, why do I need to redo this? Can I use their Sparkql endpoint? And the answer is yes, you can. You can find a way of basically benefiting from the work they have done. You plug it into your API and pops your run call. Okay, so it's really easy. And what is nice, and certainly this is what I would do, and that's what I'm going to show you as well, is that it makes it saves you from a lot of work. You can do all the testing, you can play around, you can mess around. And most likely, your Living Lab is not going to be an operational system, at least not yet. For the time being, they're labs. I mean, they may become operational, but while you're developing it, it's a lab. And in labs, you do testing. There are lots of disadvantages, but it's not relevant because it allows us to move forward, play around with the semantics and to do the stuff we have to do the interaction between the labs, to create this amazing knowledge graph that I was talking about earlier, just by basically finding a few shortcuts. Okay, right. This is hopefully this part you still understand it because it's Lego. Okay, so the fundamental theme of engineering, from my point of view, actually there is one, but that's another story. In fact, it's a joke. But my fundamental theme of engineering is you just mess around. You just play around, you do stuff, and then if it works, it works. If it doesn't work, you take it apart, you try again. So this is what engineers do. Don't think that they have ideas and plans. Forget it. Real engineers, they just mess around. They mess around until it works, and then they come up with a story afterwards why it works, and they'll make it sound like they had a plan. Most of the time, they don't. And I can say so because I'm an engineer and I've practiced this myself. So for the next few slides, I have some parental guidance, but I still want to show them. A few slides here that are not really suitable for all audiences, but they're suitable for hackers. And hackers are just people that like to mess around, that like to play around, that are creative, that haven't lost their childlike curiosity yet. They're not, however, cyber criminals. For some reason, in a common language, when you say hacker, people think they're going to be hacking a bank or something. It's a silly, most hackers are just creative people, and that's what hacking means. It doesn't mean that you're going to rob the bank. Okay, that's a completely different category of people. But anyway, so the next few slides are for hackers in this context. Don't worry, they're not too complicated. But the reason why I put them in there is firstly to show you that this is simple. Even if you're not an engineer, that's fine. If you're not an architect, that's fine. You can see it's simple. And secondly, obviously this presentation will put it out there, and that when you share this with colleagues, they can just follow this story. It's only 4 or 5 slides. There are some links, and basically when you take the next 5 slides to a colleague that has a laptop, that has the slightest knowledge of programming, they can do this. Okay, so bear with me. So if you want to implement a Sparkql endpoint, it actually means that you have to do make a server. Okay, you've heard the word server before, so that's fine. There's some details here, and just to show you how easy this is, I'm going to right now, in the next 3 minutes, create a Sparkql server, and like a magician, except magicians tend to fake it. This is not fake. There's a link here. I'm going to click on that. You can even see the link, I think, probably pop up there. And so you can do this yourself when you get it. I click on that, and it opens up a window for me. Why is it opening that window? It's this window. Here we go. Oh, it's already downloaded it. You see this thing in the bottom here? That's what it's done. Basically, it's downloaded the zip. If I open up the zip, and my apologies, I'm using a Mac. You may or may not be using a Mac, but it doesn't matter. The concepts are very similar. So by clicking on that link, I've downloaded this zip file here. You can see that, second one. My Mac automatically opens that, so that's nice. I don't have to unzip it. But so what I've done, I've downloaded this folder here, and I can open it, and you'll see that there's stuff in there. Forget about what it is, doesn't matter. I don't actually fully understand this myself. I will be very honest about that, but that doesn't mean I can't make it work. So all I have to do now, I downloaded this stuff. I open up a what we call a terminal. I've got a nice option here. Okay, let me just hide the other stuff because we don't need that. In fact, I think I can close that. I will close that too. So this I don't want either. Okay, so I've downloaded this server. Okay, again, this is, if you follow it, great. If you want to show it to a colleague, they will be able to follow it from the text. I'm just going to type this command here. You know, at the bottom it says Java, so no cheating. I'm going to just type that java-jar and then space fuseki dash server.jar. Okay, my 4 minutes are nearly up. So I hit return, I sit back, take a deep breath, and that's it. We now have a endpoint running, would you believe? And in case you know anything about this stuff, this one is running on port 3030. It actually means that on my laptop, I have a server running, and it's on port. So let me just go to a browser. Okay, just and I'm going to type that in local host 3030. Oop, should be host. Okay, and look at this. Now, if you have ever done anything in technology, this stuff blows me away. That in literally 4 minutes, I've started the server, it's up and running, and I can use it. And so again, if you're not an architect, fine. There was a parental guidance warning for you, so don't blame it on me. But your colleague could have repeated this exactly what I've just done. So let's put some data in there. Okay, so I'm gonna. It says here no data, so I have to add one, and I'm just gonna give it a name. Federated sounds like a good name. I'm choosing in memory. That does means that when I close this thing, I will lose the data, but that's fine. I don't want to keep it. Create it. Don't worry, I'm going to go very far on this. I just want to show you that we have an endpoint running. There's no data in it yet. I'm going to select some data. I have, this is actually the data I showed on the slide earlier, but it's in a file, okay? I'll put it in a file separately. I open it, upload it, and we're up and running. So we can now to actually go to the semantic endpoint, which is a Sparkql query, is the term. The next session we'll talk about semantic queries. That's what this stuff is. So we're not going to do anything. I'm just going to use the standard query that is there. What it basically says is from the data you've just loaded, give me everything. That's what this says in English. I hit the play button and I go down, and presto, here we have the data I was showing on the slide earlier on. So it talks about place of delivery, maximum volume. You can see this on the right here. The big URL is because this is all linking to our ontology, right? So we're not faking it. This is all linking to the ontology and the actual data on the right. So it took me 5 minutes to get a Sparkql endpoint up and running. It's running on my laptop, admittedly, but we could take it and just transfer it to a web server, and then everybody could access it if you give them access to it. So this is not something you should do yourself. I mean, this part, yes, you can do that. Any of you can do this, which you can just repeat what I've done. It's easy. But if you want to really run a server, then you don't need to talk to IT people. Apart from anything else, there are some security reasons why they don't want you to do that, but you could, okay? And I think some of you, and I know, for example, Rudy, I think is perfectly capable of getting this up and running. I don't have Mika's here, but he's perfectly capable of up and running. Our Spanish colleagues, this is all stuff that you can do.
I'm installing the thing right now, yeah.
Yeah, okay, there you go, Rudy. Let me just go back to help you then. Sorry, I'm now actually on the live server. Let me go back to the presentation, because ultimately, there you go. So this is, take a screenshot, Rudy. You execute the instructions here. Then before the end of this meeting, I'd like you to tell us if you have it up and running. That'll be extremely welcome. So, and if anyone else can beat Rudy to it, then please do. We're also supposed to have some fun. Okay, so that's it. I put some screenshots here, but you've just seen them live, okay? So you remember I got this thing up and running. Mine is running on localhost 3030. I think yours probably too, but that's fine, okay? So, just repeat it. We need to add some data. You know, I've shown you that, so we don't have to go over it again. And then I did the query and I got the data back. Fine. This was, I could stop here because we've got a server up and running, and I could say something like, well, thank you very much. See you next time and we'll talk about the queries. But I'm not going to do that because even though what I showed you was easy, right? Rudy's going to do it. This was easy. It was still highly technical. You didn't see an awful lot of stuff that was happening behind the scenes. There was a lot of stuff happening behind the scenes. And so you may decide that Lego is not for you, which is why we have invented Duplo, right? Keep it easier, even easier than this. And this, again, this is something you can all do yourself. So we're still under parental guidance. So if you're not following any of this, don't worry about it. We're going to go back to normal mode of communication very soon. So don't look at the details here, but there is something called Jupyter Notebooks. And what that is essentially that somebody had the bright idea that you could host computer systems where you can just put programs in and execute them. So you don't need your own server. You don't need to install it on your laptop. You install nothing at all. And our dear friends from Google, and they're not the only ones, there's lots of others, they actually have something created, collaboratories, where you just go there and you, in fact, if you click on the link, and I will in a minute, it takes you to a website that allows you to do all the stuff I've just done, but just on the website. So you don't have to install anything, right? And so even before, I don't know, Rudy may beat us to it, but perhaps before Rudy has the previous server up and running, we will have another one up and running, because this is even easier, okay? Just for your information, Jupyter Notebooks, they're specifically designed to run Python. Now, you may or may not have heard of that term. You've certainly heard of Python, as in Monty Python. That's where the name comes from. It's a very simple programming language. And if you have family or friends or perhaps kids that are getting into this stuff, they're almost certainly one of the first things to learn is Python. It's the lingua franca, in particularly in the world of AI, which is where everything is going these days. So this is totally 2022. You don't have to be embarrassed to show this to someone, because when you show this to someone, it's like, they're going like, wow, did you just do that? I can't believe it. And so you'll be revered by even your IT colleagues. So anyway, let's just click on that link. I've put some instructions here, but I'll show you on the link what we do. So I'll just click on that link, and hopefully I get a browser. Yes, I do. And so this is now the collab. I could click on new notebook at the bottom here and just type stuff in, but I'm not going to do that because I've done that before. So actually I have a federated link here. I'll click on that, but I could just type the new notebook. In fact, the slides will show you I can do that and how to do that. I'm going to go straight here. And what it does is that, let me just, I should have cleaned this, my apologies. Let me just clean that up for you. So we start from the start. There's two things here. The first thing that I want to show you is okay, wind back. What you're looking at here is a computer system that's running at Google. We just get a screen that's connected to it, and it's online, which means that when you are going to click on the link, you will also get a blank page. You may not get this data because it's my data, but you could just copy and paste it, and you can do this yourself. This is a very simple Python program. Again, don't worry, Python is not your thing. I know it isn't. The only thing I want you to look at is that I'm going to be loading some data here, okay, which is what I showed you earlier. And you may not have spotted before I loaded a TTL, which is one format, and here I'm loading JSON, but that's fine too. So that's what I'm doing. In fact, this is more complex than I wanted to show you. So let me just delete some stuff because I didn't mean to have it all here. I want to keep it simple. Okay, so this is all it takes. I won't explain the Python to you. If you have done any programming, you can read this without any further ado. The only thing I'll mention is that I'm going to be loading this data that was on the previous slides, and I'm going to run a query, and the query is here. Now, I don't know if you have any visual memory, but that's exactly the query that we just looked at in the other server. In fact, it's still here. I can look at it here. You see this here? Select subject, predicate, object, where, blah, 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 limit 25. In fact, I copy and pasted it, which is why I know it's the same. And it's here. It's on one line, but it's exactly the same. So that's one thing. We need some data, and there's some data here. And I think I uploaded it already, or if I don't, no, I didn't. Brilliant. Okay, that's even better. Then you can see how I do this. So I'm using the Google Colab computer. I'm just going to upload some data. I use exactly some data. Actually, I'm going to use the other format here, the JSON. It's the same. Okay. So now it's there. Now I'm going to run this. Okay, bear with me. It's 3 sections. You can see that I'm running one. Never mind the comments. We just ignore those. The next one, I'm actually running the query, and here it actually shows us what we have loaded. Well, we recognize that, don't we? cargo type, general cargo, nature of cargo, common consumer goods, etc. This is all the stuff from the previous slide. It's now loaded in this very nice Google computer. And I can run a query on it, which is the next line here. And what we get, believe it or not, is exactly the same output as we got with the other system that I previously created in 5 minutes. The format is a little bit nicer, but you can see here, the first line, it says Italia, veloce logistica, etc., etc. And then we have the place of delivery, Linköping, and I go here. What do I get? Okay, not in the same order. So there's the line here, you can see it. Italia, veloce logistica. And then we have the place of delivery, Linköping, okay? So it's not in the same order, but that's because these are not ordered tables. So just to summarize what you've just seen here is that I didn't have to install anything on my computer. You can run this from a browser, which means it works on any computer because you don't have a Mac maybe, but it's just there, right? It's just online. We can just run the little program and upload data. So, Rudy, did you manage to get that thing up and running or not?
No, not yet, because I get it downloaded, extracted, but then I came back to your presentation because that was too much interesting.
Okay.
But I should not be far away from it.
No, you're not. I know you're not. And I agree that it would take you 5 minutes and then you lose this beautiful implementation. So in summary, I've just put here, some screenshots. You see this, the select clause here, same data. Everybody's happy. So this is the end of the parental guidance warning. We're now back to all audiences. But just why did I show you this? Firstly, there are some people on the call that could actually follow this for sure. And there are some of you that might say, well, okay, whatever. But you can give it to your colleague. Like if Ruel gives this to Wout or something, to Cornelis, they will have a big smile and go like, yeah, I can do that in 3 minutes. Henk took 5, I can do it in 3. I can do it in 1. And that's the point, is that this is also documentation. The links are there. By all means, have a play around with it. Where does this take us? That you could consider just taking this slide deck and give it to an IT person, anyone, including your son or daughter that may be doing IT or something, or your cousin or whoever, and say, hey, can you do this for me? And the answer is yes. Okay, they can do this. However, all of this is fine, but this is not really yet something that's properly hosted in a public environment like the one that we have on the Federated website. You remember that one? There's a query thing on the website, I think I showed it earlier on. That is a proper implementation. This stuff I'm showing you here is still only running on your computer or on Google's computer, but it's not a public site yet. For that, you need to talk to IT people. There's no way around it. You can't do that yourself, and so that's it. So I'm just going to stop here because actually we're pretty much at the end of what I wanted to say. And so the last time, if you remember, we looked at the semantics side of things. What is the semantics? Where do they come from? How do we use them? How do we create this data? Today we looked at how do we actually implement that, and how do we upload this to our beautiful Sparkql endpoint server that is now running on my laptop and that is soon running on Rudy's laptop. That was today. The next time we'll look at how we're going to use that, how we're going to communicate across the labs. But we've made a lot of progress. We now understand semantics, we understand the technology, and the next time we'll talk about let's use that. So I'm going to stop here and just, again, questions, comments, reactions. Was this confusing? If so, please say so, because I always want to make it better. Who did I lose? Let me start with that question. Who did I lose along the way? And there's at least one of you, at least, so please don't hesitate. I realize this is not a good question.
You only lost me at the hacker's side.
Okay.
Thank you, Henk.
Hey, is this Rudy here?
No, this was Roland.
No. Somebody took the screen. Who was that?
I agree. It is running.
It's running. Okay, there you go, guys. So that's good. So Roland, yes, absolutely. The parental guidance part, you were supposed to be lost because it wasn't for you. But I'm very pleased that Rudy has actually done it because it really. Now, don't take this wrong, Rudy, because it's really simple. Okay, if anything, you'll agree with that. So there's different ways of doing this. And again, going back to the architect story, it is all about Lego blocks. I'll show you two different ways of doing it. If you like somebody who likes experimenting, then the one with the Google Lab thing is great because you can write your own little code and do stuff. If you're somebody that just wants to implement semantic endpoint, then the other approach is better. The architects, they have thousands of options of doing this. When they Google something like, how do I implement a Sparkql endpoint? There's so many ways of doing it that they will scratch their head for a while. I did. I know I've been scratching my head for a while. But what I've shown you is really an easy summary of how you can do this. What else? So Roland, thank you for confirming that bit was perhaps out of scope. Any other questions? What maybe question for you guys, girls? What were you expecting, and were you expecting what I've just shown you, or did you have a different expectation for this webinar, for this session?
Hi, from my side, I would like to thank you for the presentation, really instructive, really easy to follow. And after this first step, we have internally to resolve how to connect this the Apache server with our implementation and see how everything can fit together, because you're loading like we can say like offline data or files, and we would like to know how we can make that really go that query use our real data or at least some subset of our data, and we have to have a look at it. If you have any resource about that or any pointer to good resources to look how to implement that, that would be really nice. And
I do. To be honest, I tried to do this myself because what I've shown you here is basic stuff, and it's good enough for us to do experiments, for us to create little files, I should say, load them offline, do some initial interaction in the living labs. It's good enough for that. I think that we can go a long way with this without losing time on complexity. But like you, I also thought, well, it would be really nice if I could have a semantic endpoint running on our existing one record server, so we can have automatic data being transferred between the two systems. And the first answer is yes, it's obviously possible. If you are interested in the what I've shown you was it's an open source implementation. You remember when I wrote Gina Fuseki? It's in fact it's part of the Apache group that have developed this, so it's open source, and they have lots of different implementations. So what I've shown you here was a standalone server, which is okay, but in reality you need to have this system either next to or integrated into your own living lab server. That's the challenge. And so one of the things I played around with for a while was that they actually have a what's called a Docker implementation. And so if you know Docker, which I don't, I'll be honest with you, I played around with it, but I'm not an expert at roughly anything, but I know very little about a lot of things. And so I know that Docker exists. And I know that they have a component or whatever they call it that you can just install there. So if you're a Docker person, then probably instead of doing what I've just shown you here, implement Docker. I'm pretty sure that if you do that, you can probably create those links between the Docker server and your server. That is one way of doing it. The other way is that again, still with Apache Jena Fuseki, they also have libraries that you can implement. And so this is all written in Java, if you're a Java outfit, if you're a Java group, then you'll be able to read that and implement it. I used to have a colleague that was really good at Java. I'm pretty sure if I had given it to her, she would have up and running within a day. But unfortunately, she decided that there were other places that were more interesting than working for me. And so I don't have that resource anymore. But one of the reasons I showed you the Python as well is that if you're a Python shop, as we say in the professional circles, if you're a Python shop, then in fact, on the page that I showed you there, it says something like, I think it's import RDF lib. By doing that, you have everything you need. And so you can if you're, I don't know if you're a Python shop, but if you were, you would probably have this up and running before the end of the day on your existing environment. But my guess is that you're not a Python shop. In fact, what are you? What systems do you guys use in your lab? You know, is it Java?
Yeah,
is it Python?
Yeah, we currently have a microservices architecture with some services implemented in Java. Yeah. But I guess that we could use some other implementation if we needed. Each service has its own language, or you can have different languages. So it won't be a problem. But my main problem is we have this. But maybe it's for an upcoming session. We have this all this data in our model, and I would like to understand how to send this to our because we don't actually use a triple store or anything. We are using other types of data stores. So that's my what the step that I'm missing currently. It's that one. How to send the data if it's with each interaction of users or external systems, or how that communication between the traditional part and the semantics part should happen.
Right.
So, but I have a lot to look for still. So.
Yes, but I think it's an extremely relevant question. I mean, my comment, as you rightly interpreted, had to do with architecture. And yes, I agree with you. I mean, if you guys are doing Java, then I'm pretty sure I'm pretty sure that your Java colleagues will be able to find what they need in the libraries that are there. But your question is a different one, and I've asked myself the same question: is how do you link, or how do you essentially create a triple store from what is probably a relational database or some other database? I don't have any sort of canned answers for that. I don't have any easy shortcuts for that. What I can tell you is that maybe I'll explain what we will do on the One Record side, the Internet Logistics, is that we have actually described our data with an ontology. And so any data that we have is actually already in the right format. And so most likely what I would do is to take some of that data, not all of it, perhaps, I don't know, to say with the example we had, maybe some estimated time of arrival data or something like that we have in our current database, extract that and put it in the right format. Now, because we use an ontology, I suspect I can do that without an awful lot of transformations. But if you don't, and I think that's your case, and I think it's the case for most of the living labs, it wouldn't be too hard, or it shouldn't be too hard, to write a little program that extracts data from your current database and converts it into one of the formats that we can use in the Sparkql endpoints, whether that is TTF or whether that's JSON, LD, one of the RDF formats. To do that conversion, I think will be a very simple script. And for the purpose of testing, you could say, well, I would like to be able to share my ETDs, my ATDs, my ETAs, my ATAs. I want to be able to share perhaps certain status details. Just decide what subset you would like to be able to share across a Sparkql endpoint. Write a little script that extracts it in the traditional way, goes to your database, gets the data, and writes it into what is essentially a very cheap triple store, which is just a file system like the one I've used here. That's what I would look at, but then if I take this to the next level, and since you're using Java, there are actually implementations that allow you to do an automatic conversion from what is it, Java object library? No, what is it? Oh no, it's the other way around. Sorry, I'm confusing you. We use something that converts an ontology into a Java API, a Java objects. They call it an object triple mapper. And so there are tools that you might find, I don't have them for you, that will actually do what you need to do. For example, to map a normal relational database to a triple format. There may well be tools to do that. But if there aren't, I would, like I suggested, write a little script, does an extraction, does it maybe every minute, every hour, whatever time it does, and maintains just a set of files that is in the correct format. That's what I would do as a starting point.
Yeah, I think we can do that in our Living Lab. We actually use an ontology. We're working with also with TNO to evolve the federated model. So we use in our relational data model a lot of the entities we have in the federated ontology model. But yeah, I guess for the first step, until we get comfortable, we can do that some ETL transformation and to move some subset of data to the semantic part.
Yeah.
Just for
I don't want to go too deep into it here because of the others, but I'm happy to show you what we call the object triple mapping that we've implemented with Java as well. And that actually it basically creates an API out of an ontology. And so happy to show that, because if you have already got the ontology, even for your own stuff, then that next step is automated. You don't have to do anything. But I would still do the ETL conversion just for playing around. But there is a robust implementation that would do the automatic translation from your ontology to a what is essentially a triple store.
Well, that would be great. Thank you.
Yeah. Okay, you're welcome. Any other questions?
I can only confirm that this is what I'm doing also within the Living Lab 17. I read the relational database or in such a way that I obtain initially an XML or JSON-LD format, and then I also developed a little script to generate the triples. And that's where I am at this moment. But I prefer to do that manually so that you know exactly what you are achieving out of it. Yeah.
I think that's right, Rudy. And one of the reasons why that relatively simple approach is appropriate here is that we don't really know yet what we want to exchange between the various Living Labs. And so it's all quite, we're just exploring things. When you get to a point where you have systems, and that may well be the case for the simpler project, where you say, no, this has to be production ready, then yes, then you have to go to the next stage. But for all the other things, for now, that simple approach of just extracting some data, converting it into one format and then perhaps in another, and then linking it to one of those simple Sparkql endpoints that I just showed you, we will be there. And if you step back from it, and I don't know whether Roland would have any comments on this, but the way I see it is that if at the end of these little 3 sessions, if at the end of some relatively simple work that we can each do, we have an environment whereby one lab can contact another lab's Sparkql endpoint and get some data using a simple query, perhaps passing it on to another lab. These sort of relatively simple things is what we're trying to demonstrate when we talk about semantic interoperability, when we talk about knowledge graphs. I mean, we don't use that term, but that's what it is. When we talk about exchanging data between living labs, that relatively simple implementation would be a very powerful demonstration of what we can do. Then, when you give this stuff to real experts, which is not me, you give it to real engineers and real architects, they can make this stuff robust for you, no problem. But as a living lab, interactivity, interoperability, this is good enough, I think. Any other comments? I see Mika. Mika, do you have any comments? Are you coming to Amsterdam?
Yeah, I think we are coming to Amsterdam to
Okay.
tell you more about this stuff.
Okay. What do you think? I'm not going to insult you by asking if you could follow this, but could you follow this?
Sure. I had little issues. What I'm mostly worried about is that you make it sound so simple that Matti and Lasse will be like, why is it not up and running yet?
Well, listen, Rudy has it up and running. So I think if you haven't got it up and running by the end of this session, then yeah, I think you need to work late. No, this is not complex stuff. This is the hardest part, I think, is getting your head around semantics, the technology, how do you query. There is stuff that it's the big picture, I think, is complex, to be honest. But when you dive into the details, it's not so complex. It's Lego.
Yeah, and it will take some time to get actual systems around it. But
yeah, for sure. But next time, we'll basically start from where we are. We now have a working endpoint. You'll all have working endpoints by the sounds of it. And then we can just load more data. I think one of the things I'll do is I will review the examples that I've given you last time. They're not 100% in line with the ontology. And that was fine because I just wanted to demonstrate how to do this. For the next time, I'll try and have something that's a little bit more in line with the thinking, but also perhaps a little bit more, I don't want to use the term complex, but a bit more complete, a bit more data in there that allows us to do some simulations of, okay, I'm in this lab and I'm interested in finding out what's happening in that lab, and this is how I do that. So next time we'll look at that. And then if necessary, we can start again in the beginning and revise until it's all working. But that's the plan for next time. While I'm at it, are there any other things that I should have covered that we can pick up next time? If you can think of it now, that's great. If not, feel free to shoot me an email.
Maybe, Henk, we could take a real simple example of a flight whereby we have a number of events that relate to the flight, departure, arrival, something very, very stupid, so that everyone can see what are we talking about and start from there, or whether it is a flight or something else.
Sure, we could do that. We could, in fact, one of the things that certainly for myself, Rudy, I would like to do is to take some aviation-related data and link it up with this environment, because we haven't done that, I'll be honest with you. But I'd like to do that, and then we can do the same for other types of transport. But yes, something, yeah. What I've shown you here is Lego Duplo stuff. And I'll go to the next level and go to maybe Lego Technique or whatever they called. Something a bit more sophisticated, but not so much so that we get lost. Okay. All right, listen, I think actually it's time. If there are any other comments or questions, this is a good time. So I'll just shut up for a second.
I think from the federated perspective, I think we would like to thank you again for this very marvelous presentation. It's still simple to me, but you also indicated what is federated proven, not relating to the living labs, and maybe the suggestions you made can also be taken on board during our next workshop, where we do a tour the table of the different living labs and see whether they are federated proof according to Henk. Whether they build an API including even a Sparkql endpoint and how they manage that. And that might be an interesting half-day session in order to check whether everybody more or less is in tune with what you're explaining to us. And it doesn't need to be that they need to be on a sophisticated level, but sometimes I see living labs developing APIs on which you ask yourself, that has nothing to do with Federated. And that's what we should level up a bit for the next time, I think. Thanks.
Okay.
Well done.
Well, I will make sure that the third session here, third and last, the trilogy as Rudy calls it, I'll make sure that the trilogy is finished before that meeting in Malaga. So we've got the full story. And one of the things is that realistically, I don't expect many labs to implement this overnight, but I do expect them to think about it at least so that they can ask some of these questions and give intellectual answers to these questions. I'll make sure of that. There was something else I was going to say, and it escapes me. That doesn't matter. Clearly, it wasn't important. So with that, thank you very much. I will, Roland, I will send you the presentation and I will get the recording to you as well. And I think that's it. Thank you very much. Thank you for your attention, as they say.
Many thanks.
Okay.
Thank you.
All right. Take care.
Thank you.
Bye-bye.
Thank you very much.
Thanks.
Thank you very much. Thank you for your presentation. Thank you very much.